right. Of course it did that. Let me get that right back up. Here we go. Okay. So number one, we want to verify whether or not these function pairs are inverses by using composition of functions. So I have to choose one of my functions to be the outside function, and the other one is going to be the inside function. When I'm looking at these two, I would probably choose r of x to be my outside function, because whatever goes outside that 2x right there, I'm going to make a substitution where x is, and so I'm going to have to distribute that 2. And distributing a whole number is usually easier than distributing a fraction. So I'm going to make this my outside function. And that means that I'm going to use this one as the inside function. So I'm going to have r of g of x, like this. So I'm going to recopy all of the function r of x, except when I get to the x part, I'm going to put parentheses there, just like if I was substituting a number in. So I'm going to recopy the 2, and then I'm going to leave some parentheses here for my substitution, and then minus 6. So just like as if I was putting a number in the place of x. But instead of a number, I'm going to take this whole function, g of x, and I'm going to pop it into those parentheses. So I'm going to have negative 1/2 x plus 3. And now I'm going to need to distribute. So I'm going to take this 2 and distribute it to both pieces in here. 2 times negative 1/2. Well, anytime I multiply something by a half, I want to know what is half of that. What is half of 2? You can unmute your mic or you can answer me in the chat. What is half of 2?
1.
Awesome, thank you. And because it's a negative 1/2, this is going to be a negative 1. Thank you, XL, as well. So I'm going to have a negative 1x, and then I distribute the 2 to the 3, and when we distribute, we're multiplying. What is 2 times 3?
6.
6, awesome. So I have a plus 6 here, and then I have to bring down my minus 6 here. And then I need to finish simplifying, so I'm going to combine any like terms together. Well, these two right here are like terms. What happens when I combine those two?
You get 0.
Absolutely correct. And Axel, I see your responses in the chat as well. So I get negative 1x when I finish simplifying. So does that mean that these two functions are or are not inverses of each other? Awesome, Axel, I see your message in the chat there. These are not inverses. What would it have to look like if they were inverses? The only way that they can be inverses.
They would have to only just be x.
Only just be x. And Savion, you're absolutely right. If it's okay with you, I'm going to go ahead and share your comment. He said because it's a negative right here, this is not only x. It's negative. It would have to just be an x, no other numbers, no symbols, no operations, no nothing. If you wrote it down as a 1x, that would be okay, because 1x is the same thing as just x. But the negative part means that it does not satisfy the condition to be inverses. Awesome job with that, guys. Okay, so now we're on to number 2. Number 2, it says to solve by factoring. So solve, synonyms for that, those are roots, X-intercepts, zeros. We're finding solutions. So what I need to do first is look for a GCF. Do we have a GCF here? Yes. What is our GCF? What will go into all three parts, A, B, and C? Awesome. Thank you, Axel. So our GCF is 2 here. Somebody asked a really good question in first period, and they said, what about this 0 over here? That's a great question. We don't usually look on the other side of the equal sign for GCFs. We'll just write it out in front of parentheses, but that equals 0 there is not a problem whatsoever. In fact, how many times do we look at a problem like this and it actually starts with a y equals? And we don't worry about the fact that a GCF doesn't go into the y part. That's all right. So I'm going to take a 2 out of each piece here. And so what that would leave me with, I would have 2 and then x squared minus 4x plus 4 equals 0. So we got our GCF out. Beautiful. So now this is what we're going to factor. What are our values for A, B, and C? Let's start with A. What is our value for A here? X squared. What's the number in front of the x squared? Absolutely correct. So we're going to use 1 as the value for A. What is our value for B? -4. And what is our value for C?
4.
+4. Thank you, guys. All right, so I know I'm going to need to make an X. Can I use my shortcut here? Or do I have to do the full area model? I can use it. I'm allowed to use it anytime my A value is 1. So all I need for this is the X. We're going to multiply the values for A and C together up on the top. So I'm multiplying 1 and 4 together. That gives me a +4 up there. My B value, which goes on the bottom, is -4. So I need two numbers that when I multiply them, I get +4. And when I add them, I get -4. What two numbers are going to do that? And Axel, you're absolutely correct on your last comment in the chat there. What's going to multiply to a +4, but add to a -4? Awesome. -2 and -2 is what will do that. So when I write this down in factored form, we have our GCF on the outside, and then I'm going to have x minus 2, and then another x minus 2. Because we had the same thing. I could also choose to write this, since these two factors are the same and they're being multiplied together, I could write this as x minus 2 squared. Has the exact same meaning. And so what all of this is telling me is I need to solve this yet. I need to take my factors close. It's actually called a perfect square as opposed to a difference of squares. But yeah, good eye there. Since my two factors are identical, when I set them equal to 0 to solve, I'm going to get the same answer both times. Let me scoot that over just a little bit. There we go. And so I'm going to solve these both for x. So I'm going to add 2 to both sides. Out of both of these, I get x equals 2. That means I only have one solution because it was the same thing both times. So my solution here would be x equals 2. Or you could write that as an ordered pair. Your ordered pair would be 2, 0. The reason that we only have a single solution here, what this tells me is that if I were to graph this, my parabola is going to come and touch the x-axis right there at positive 2, but it's not going to go all the way through it. This root is the vertex. Anytime you have just one solution, that's what's happening. Because if the vertex is not touching the x-axis, it would have to go all the way through it, and then it would have to come up somewhere else. So this is one of those situations where we have only one real root. If we had two separate answers, pretend we'd got -2 and +2, then the vertex would not be on the x-axis. It would not be our root. All right. We are going to study for your midterm, which is this Thursday. That's what we're going to spend the rest of the class period doing. So if you have your books with you, go ahead and open them up to page 77. If you don't have your books, that's okay. You can just grab a piece of paper and follow along with us. Give you guys a minute to get things written down. All right. On this problem, I want to take the equation that I have right here, and I want to change it into vertex form. Well, I know my vertex form is my AHK form. What form is it in right now?
General.
General form, yes. Sometimes we call this standard form. Well, if I want to take it from the form that it's in right now and put it into this form, the thing that I notice about this form, it's got parentheses that are being squared. And so that gives me a tip off. Yes, that's absolutely correct. We're going to do parentheses around the A and the B. This is going to be the process of completing the square. So I'm going to draw my best rendition of a square over here. Squares have 4 equal sides, and so that's what I'm trying to give it. Put parentheses around the A and the B, and I'm going to leave C out. So C gets left out and shoved back here. I'm going to take my A value, my x squared, that's going to go up here in the upper left. So I've got almost all the pieces that I had in my original general form represented over here. I've got the x squared, I've got the plus 11, and then in the chat I see we're going to divide the b value in half to figure out what goes in these two spaces, because since squares have all equal sides, it has to be the same exact thing in those two boxes. So I'm going to take this and cut it in half. What's half of 6?
3.
3. So I'm going to have a 3x in each of those boxes there. 3x and 3x. So what I have over here right now in my little square and with that plus 11 outside, this is all the original pieces of my polynomial. X squared, when I take the 3x and 3x and I put them back together, I get 6x. I have that plus 11 out of back. So let's figure out how big the sides of my square are. What's going to go on the outside as I figure out how big my square is? X plus 3, thank you. X plus 3 and x plus 3. They have to be the same or else it's not a square. Absolutely correct. This is why it's called completing the square, because right now I have this empty spot here. All the numbers that are inside my square and then that plus 11, those are all part of my original equation. I'm going to introduce something new to complete this square. I'm going to take this number, so 3, and I'm going to multiply it to this number up here, so another 3, and that's what I'm going to introduce into this equation to finish this square. 9, absolutely correct. But I don't want a new equation. I want the same equation just in a different form. So I've introduced something new to keep it balanced, to keep it the same as it was before. If I bring something new in, I have to take it back away again. So whatever I introduce there, I have to subtract from the back. Yep, and we're always subtracting because we're always adding something new in that bottom box. And so we always have to take it away again out at the back. So now I'm looking over here. What is 11 minus 9? Positive 2. Thank you, Alex. So there's all the pieces that I need for my vertex form now. My vertex form is going to be y equals, we didn't have an a value that we had to pull out the front. If there'd been a number in front of the x squared, then I would have needed to do that. But I don't have that in this case. So I have x plus 3 squared, those are the sides of my square, and then I have plus 2 at the back. So now I have my AHK form. So now that I have an AHK form, what is the vertex? What is my vertex? Absolutely correct, Excel. It's going to be -3, 2. Remember, this is my H and my K, but H in the equation is always the opposite sign of what I see. All right, since we're right here with this, let's go ahead and do axis of symmetry next. The axis of symmetry is always going to go up and down, cutting my parabola in half. Since it goes up and down, it's going to have to go through which axis? If it goes up and down, it has to go through, thank you, Alex, it has to go through my x-axis. So this is going to be an x equals, it's going to be parallel to our y-axis, but it's never going to touch it. If it's going up and down, it's going to have to cut through the x-axis. And if it's going to cut my parabola in half, it's going to have to go through the vertex, because that vertex is the very center of my parabola. So if it goes through the x-axis, I'm looking at the x part of that ordered pair, which means it's going to be x equals what? X equals -3. Absolutely correct. All right, let's do domain and range now. Domain for all of my parabolas, all of my quadratics, no matter what, whether it's the parent, whether it's a transformation, what is my domain always going to be?
Infinity, negative infinity.
Yes, absolutely correct. We always start with the smaller thing, just like we read in English from left to right. So I'm going to start with the negative infinity, because that would have me looking to the left. So I start with my negative, and then I move to my positive. But Jimmy, you were absolutely correct there. And then for my range, for the range, I need the highest and lowest points. So I want you to look at this vertex form. Pay special attention to the A value. Is this parabola going to open up, or is it going to open down? Will it open up, or will it open down? Yes, it's going to open up. Our A value is positive. And so when we graph this in a little bit, we're going to see, here, I'm just going to do a little sketch like this. It opens up. Because A is positive. If A was negative, then it would open down. So the vertex, in my bad little sketch, here's the vertex. Is that going to be a maximum or a minimum? A lowest point or a highest point?
Since it opens upwards, it's the lowest point.
Yes, since it opens up, it's the lowest point. So this is a minimum. And that's important for me to know, because that means my range is going to start there. That's the lowest it ever goes, and then it goes up forever. So when I'm talking about lowest and highest, those are Y value things. Range tells me about the Y values. So look at the Y part of the vertex. That's the lowest this ever goes. Where is the lowest? What is the Y part of that vertex? Two. That's absolutely correct. 2 is the lowest this parabola ever goes. So axis of symmetry uses the X part of my vertex. Range will always use the Y part of my vertex. If it's a minimum, then I start with the Y part of the vertex because that's the lowest. And then it would go on to infinity because it opens up. If my parabola opens down, it doesn't have a lowest, so it would start with negative infinity, but then it's going to go up to my maximum, which is still going to be my vertex. So I'm always going to use K. I'm always going to use the Y part of the vertex here. All right, transformations from the parent. Transformations from the parent we want in words, things like stretched, compressed, reflected, left, right, up, down. That's what I'm looking for whenever you see this word transformations. So let's start by identifying what are the values for AH and K. Absolutely correct. What is our A value here? 1. H, that came from my vertex, so that's -3, and we have to be careful about H because that's the tricky one. And our K value is 2. We always multiply things by A. If I multiply something by 1, will it change my number at all? No. And so if my A value is 1, this means no change. And I'm only describing things that are different or changes. So I wouldn't say anything about that. And then in the chat, I see that Axel has already put in that this H value of -3 is going to send my graph to the left 3. And then the K value of +2 is going to send the graph up 2. So that's what I'm looking for, that type of thing. Anytime you see describe the transformations or what are the transformations. And then the last thing they want me to do is graph the function. I'm going to start off by graphing the parent. The parent function is y equals x squared. So on my table, I'm going to have x and y. This is our input, which means we get to choose our x's. And I have my 5 favorite x's that I like to choose. -2, -1, 0, 1, and 2. And then I look over at my parent function and I'm looking at the rule. It says I'm going to take my inputs and I'm going to square them. So we're going to square all the x values. So what do I get if I square -2? If I take -2 and I multiply it by itself? Absolutely
4.
Correct. We're going to get a +4. And then when I square a -1, I get a +1. 0 squared is just 0. And then my outputs start to repeat themselves. Good work. So I'm going to go plot those points. On the test you guys took, the Unit 2 test, and on the midterm, there are points just for plotting this parent function. So please don't leave that part out. You do get points for doing that. All right, I did that mostly okay. Now I'm going to apply my transformations to this. So whatever we said in words was going to happen, that's what I need to see happen on my graph. We said that this graph was going to go to the left 3. So I want to take all of my x's and I'm going to add our h to it. Our h value was -3, so I'm adding -3 all the way down. If that seems confusing to you, you can also go and look at the graph. For my parent function, that first x value is -2, and if I go to the left 3, 1, 2, 3, that puts me over here at -5. So that new x would be -5. I can do the same thing for the next x value. The next x value is -1, and I want to go to the left 3. 1, 2, 3. That puts me right there at -4. And notice my x's just keep going in order from there. -3, -2, and then -1. So there's all my new x's. Then we need to find our new y's, our new outputs. First thing we do is we multiply by our a value. Well, our a value is just 1. So it's not going to stretch it, it's not going to compress it, it's not going to reflect it. There will be no change to any of my y values because of multiplying. And then we will add or subtract whatever our k value is. And k happens to be a +2. So we're going to add 2 to each of these. So I do 4 + 2, and I get what is my output. Try one more time for me, 4 + 2. There you go. And then I do 1 + 2, and I get what? 3. And then 0 + 2, and I get 2. And then my y values start to repeat. So I have another 3 and another 6. These are the points that we are going to go in and plot. -5, 6. -4, 3. -3, 2. -2, 3. And -1, 6. Here's my transformed function. Just like that. Awesome. Good work so far, guys. Let's go try another review problem here. Let me see. Want to make sure that we have enough time for things. Let's do this one. I have a graph to look at, and I'm supposed to come up with 2 forms. This is on page 89 in your book. So again, if you have your books, go to page 89. If not, just do this on paper with us. That's perfectly okay. What feature of the graph do I want to look at if I'm going to try to write something in factored form? Look at what? The roots, yes. Look at the roots, the x-intercepts. Factored form, y equals a times x minus r1 times x minus r2. I'm going to be able to get this part and this part from the roots. So where are my x-intercepts here? Awesome. -7. So x equals -7 and +3 over here. Beautiful. But I need factors. Factors always have to be equal to 0. So how would I take something like x equals -7, get it equal to 0? What would I need to do to both sides to make that -7 cancel out? I need to add. So I'm going to add 7 to both sides so that I can get my factor. So x plus 7 equals 0. There's that piece. So this is a factor. And then I'm going to do the same thing for the other root. This is x equals 3. Do I still add on this one? No, this time I'm going to subtract. Good work. So I'm going to subtract 3 from both sides. X minus 3 equals 0. There's that part. So that means this is another factor. So I can write that down over here. What's the only piece of my factored form that I'm missing now? What's the only thing that I still need to substitute in something for? Close. X's and Y's are my variables, and I want to leave those in the equation. It's the other piece. What else do I need to substitute a value in for? To have the equation.
Is it A?
Yes. We need to find A. We're going to substitute in for Y so that we can find A, but we still need to find this piece. So I've got this graph. Any points on this graph, I can substitute in for X and for Y to be able to figure out what my A value is. I just can't use my two roots because I've already used those numbers as part of my factors. If I take either of those roots and substitute them in, I'm going to get 0 equals 0, which is true, but not helpful. So I want to find somewhere on this graph that it's crossing nicely. I see a couple places. Let's see, it looks like this is a nice ordered pair. That's 2, 4. This one looks like a nice ordered pair here as well, 1, 8. Here's an ordered pair that I might be able to use. -5, 8. Looks like there's one right about here. Not really sure if I'm seeing that right. I'm just kind of looking at the graph, making my best guesses here. What ordered pair would you guys like to use from the ones that we think we see? What looks good? Two, 4. That works. Okay, so we're going to use the pair 2, 4. So I'm going to put 4 in the place of Y. And I'm going to put 2 in the place of X. In both spots for X. Has to go in both locations. All right, so now I'm looking over on the left. Order of operations says parentheses first. So I need to simplify these parentheses and these parentheses. What's 2 plus 7?
9.
9. And then I need 2 minus 3. What is that?
-1.
-1. What's happening between those parentheses? What operation is happening there?
Times.
Times, yes, these are being multiplied here. So 9 times -1 times A, that would give me -9A. If I want to get the A all by itself, what would I need to do? How do I get the A all by itself now? Divide, absolutely correct. Thank you guys. Got a whole bunch of people answer me on that one. So I'm going to divide both sides by -9. Means my A value is kind of gross, but that's okay. We have A is equal to -4/9. Does that somewhat match our expectations as far as negative or positive when I look at this graph? Does that seem to make sense? Yes, it's opening down, so I would expect it to be a negative A value. All right, so in factored form, I would have -4/9, and then x plus 7 and x minus 3. That's how I would answer this first part. To take it and put it into standard form now, I'm going to take this factored form, and I'm going to use order of operations on it. First thing I'm going to pay attention to is my parentheses, and I have to use double distribution here. So I'm going to take the x and distribute it to both pieces first. That would give me x squared minus 3x. And then I have to distribute the 7 to both pieces. So plus 7x minus 21. All of that is going to get multiplied by -4/9. I'll do that after I combine my like terms together, because that looks like it's going to get a little bit messy. So I'm going to combine these two together right here. And so I would have x squared plus 4x minus 21. And that's all getting multiplied by -4/9. So I'm going to distribute that to each piece. And without taking up too much time here, I would get -4/9 x squared. This would be -16/9 x. We multiply the numerators, but not the denominators. And then over here, this would give me plus, because it's negative times a negative, 48/9. I can technically reduce both of those by 3. And so finished form, standard form of the equation, if I fully reduced it, would be y equals -4/9 x squared minus 16/9 x plus 16/3. Now, come the midterm, I'm not going to give you some gross fractions like that to work with, but when we're just practicing, that's okay. All right, here's what I need you guys to do for tomorrow. You're going to continue working on reviewing for that midterm exam. Today's lesson page down here at the bottom, Unit 3 and Midterm Test Review. Please click on that and complete that. There's about 20 questions, right? About 20 questions on there. It's not due until the day of your midterm, which is Thursday, but I need you to open it up and work through every piece you can. So anything you have questions on, you have time to ask me about. All right. That is everything from me, and I hope you guys have a fantastic rest of your day. The next class starts at 9:01. So you guys have 7 minutes from right now. 9:01 is your next class start time.